You want to put all these on a little sketch of a graph. X equals 0, the y-axis. X equals square root of pi over 2. It's a vertical line somewhere over here. And if you graph this function, you'll see that it's made perfectly so that it stops right up here. And then y equals 10 is up here. Let's see. I want the region bounded by all four of these things. How are all four going to play a part? I think they want this region. And so to do that, what we want to do is we want to take the entire region that's revolved around the y-axis, which ignoring that y equals 10 sine x squared. We want to take this region, subtract it by I just don't know if they want this region or this region. Here we can do it both ways. Because both are bounded by all four of those functions. Okay, so this entire region here, this is just a right cylinder. Right? Here's the top. Here's the bottom. It has a radius, a constant radius of square root of pi over 2. It has a height of 10 because we're revolving this around the y-axis, right? So that's the bottom of the right cylinder I just drew. So it has a radius of square root of pi over 2. It has a height of 10. So the area of the big region is pi r squared. The radius is square root of pi over 2 times h. And then if you simplify that, square root being squared, that gives us pi over 2. Pi times pi gives us pi squared. And then 1 over 2 times 10 gives us 5. So that's the area of this big region. And I think what they want us to do is subtract out the area of this region here that's bounded specifically by that region around the y-axis, because that will give us this shaded region over here. So what we're going to do is we're going to use the method of cylindrical shells to find out what's the volume when we take this region, the two-dimensional region, and rotate around the y-axis. We'll subtract that out of the big region, and that will leave us with this region here. So it's 5 pi squared, the big region, subtracted by the integral. We're going from 0 to square root of pi over 2. For using the method of cylindrical shells, it's 2 pi x times 10 sine x squared. And we can factor out that 2 pi. And then and a 10 too. Let's take all of it out. 2 pi times 10, we can take all of that out. 20 pi on the outside of that integral. And now it's x times sine x squared. You want u to be x squared here when you evaluate the integral of x times sine x squared, because du is going to be 2x. So we need a 2 here. And we can't just shove a 2 in there or else it's not the same exact problem. We have to compensate, balance it by multiplying it 1/2 the outside. So here, putting that all together, we've rewritten as 10 pi 0 to square root of pi over 2. And then it's sine u du. Actually, these won't be the limits of integration for u. I should be careful about that because that was for x. We'll put those back in at the end. The antiderivative sign is negative cosine because the derivative of cosine is negative sine. So negative would make a positive and bring us back to where we want to be. But instead of putting u in here, I'm going to replace it, get us back in terms of x. We just used u to help us evaluate the antiderivative. So if we plug in the square root of pi over 2 in here, square root of pi over 2 gets squared. So cosine pi over 2 is 0. So that's negative 0, or in other words, just 0. Subtracted by what happens when you plug in 0 for the limits of integration. Cosine of 0 is 1, so that's minus a negative 1. So it looks like our final answer is 5 pi squared minus 10 pi.